All right, welcome back to Applications of Calc 2. We are looking at problem number 3a, which says construct a fourth degree Taylor polynomial for the functions. We have f of x equals 1 plus x raised to the 1/4 power. We want a fourth degree polynomial. Okay, Taylor polynomial at x equals 0. Okay, so you will find a function, you will find the formula for generating Taylor polynomials at the bottom of your test. And all it's going to say is T of x is equal to the sum, as k goes off from 0 off to whatever, um, of f, and then there's a little parentheses here, of k, just meaning the kth derivative. So we're going to start from 0, we get the 0th derivative, of 0 times x to the k divided by k factorial. Okay, and we can just go through and start that. So to start this thing off, we're going to need a couple of few derivatives. Okay, so the 0th derivative is just the function as is. So we could type that in, f of 0, and this is f of 0. The 0th derivative is just 1 plus x raised to the 1/4 power, and be done with it. Then we're going to start taking derivatives. So the f prime of x, this is going to be, let me put the fourth in the right place because that's not where it is. All right. Um, so we're going to say this is equal to 1 plus x to the 1/4. Now we're just going to take the 4 down in front. So this is going to be 1/4 x plus 1. You could write 1 plus x or 1 x plus 1, doesn't matter. So x plus 1, and then we say 1 minus, right, or 1/4 minus 1. So we end up with a negative 3/4 here. Just going back to calculus 1 and taking some derivatives here. F prime of x, okay, F double prime rather, we're going to say this is negative 3/4, right? This negative 3/4 comes down in front times 1/4 x plus 1, and then we're going to say 3/4 minus 1, or negative 3/4 minus 1. So it looks like we're going to get minus 7/4. Okay, let's clean this up a little bit. So this is going to be negative 3 over 16 x plus 1 raised to the negative 7 over 4. Okay. Third derivative, 1, 2, 3. We're going to say this is going to be negative 7 over 4 times negative 3 over 16 x plus 1. And then we're going to say 7/4 minus 1. So this is going to be minus 11/4. Let's clean this up a little bit. 7 times 3 is going to be 21. Negative times negative is positive. 4 times 16 is going to give me 64. So we have 64 x plus 1 raised to the negative 11 over 4. All right. Last one, we have f4. Sometimes people write it in Roman numerals, sometimes not. Either way. So we have this is equal to negative 11 over 4 times 21 over 64. Okay, and then we have our x plus 1, subtracting 1 again from this, and it looks like we have negative 15 over 4. Okay, and let's go ahead and double check 11 times 21. I think, did I get something for that? 11 times 21, I got 231, so this is equal to negative 231, and then 4 times 64, and this is over 256, and then we have x plus 1 raised to the negative 15 over 4. So we've collected some derivatives here, okay? And that's the first little thing to deal with this. Then fortunately, there was no chain rule with this one. If there's a chain rule, you have to remember to multiply by that as well. You might have product rules after this. This can get messy. So just be careful as you're going through this. That's why it's only a fourth degree polynomial, because if it does get messy, I don't want you to be here trying to take a gazillion derivatives that just get progressively larger and larger and larger. Now we have to set x equal to 0. Okay, fortunately, 0 plus 1, because x is going to be 0, 0 plus 1 is equal to 1, raised to any power is going to be 1. So I don't have to worry about getting the calculator out to say 1 to the negative 15/4. It's just going to be 1. Okay. So we can go ahead and write down what's going to happen next. So we just need the coefficients. So my 0th derivative here, all right, I got this, the 1/4 power to the 0. We had 1 plus 0 raised to the 1/4 power. This was just going to be, that's just going to be 1 x plus 1 raised to the 1/4. So we can go ahead and deal with that. So we're going to say, okay, we need our 0th polynomial. So we're just going to get, that's going to be 1. I just plugged in 1 into my x, or plugged in 0 into my x plus 1 and raised it to a power. Plus, and now I need my first derivative. That was 1/4. Okay. The x plus 1 part is going to be 1 raised to whatever this was. Raised to the -3/4 is just going to be 1. And it's going to say times x divided by 1 factorial, which is just 1. Okay, my second derivative, so f prime, f double prime rather, that was -3/16. Okay, the function value at 0 is also 1, so we're going to say -316 over x squared times x squared over 2 factorial. And then when we go to our 3, we're going to be adding 21/64 x 3 over 3 factorial. And then finally, we have -231 over 256. Again, we put in 0 here. We get 0 plus 1 raised to that. We have x to the 4th over 4 factorial. Okay, and that's pretty much what we're looking at here. So I have a 1 plus 1/4 x, okay, minus 2 times 16 is 32. So we have 3 over 32 x squared. Let's see, we have 64 times 6, because 3 factorial is 3 times 2 times 1. So 64 times 6. So let's see, that was 384. So we're going to say plus 21 over 384 times x cubed minus, and then we have 256 times 4 factorial. 4 times 3, 12, times 2, 24, times 1. So we have 256, okay, times 24. There we go. So that's 6144. So we have 6144. Here's our 231 x to the 4th power, and that's going to be our 4th degree polynomial that approximates our x plus 1 raised to the 1/4 power. Again, when you have like, an x plus 1 raised to the 1/4 power, this is an even radical. So if you ended up with like a -2 in here or something like that, where it's going to be a negative value and there's going to be some problems with it, you might want to change to Taylor polynomials, because Taylor series does not really have a problem with the fact that there's domain issues with the radical. Okay, so that's how that tends to work. I think, did I do this? Desmos? Yes, I did. So I did type this into Desmos just to see what the function would look like versus the red function. The red function is the real function. That's x to the 4th plus 1. And you can see like around 0, okay, this is actually pretty good as far as an approximation. So you can see like it does approximate this guy pretty quickly. We're not going to have the same kind of radiance of convergence, but we're not asking you to find that because it's a little bit harder for this problem. So we don't really ask you to do that, so you don't have to. But just finding the polynomial that approximates the 1 plus x raised to the 1/4 power. Okay, and that's pretty much what we're asking you to do. Okay. So with that, I'm going to say thank you very much for watching the video. Good luck studying with everything. And then notice like the wording of the problem. This one said you construct the Taylor polynomial to degree 4. Not every problem is going to have, if it just mentions Taylor polynomials, there's other problems that have you consult a table of Taylor polynomials, because I'm asking you to do something else, but I do have to see if you can construct them as well. So be careful to pay attention to the instructions. This one says you construct a Taylor polynomial as opposed to consult a table. Okay, so just be careful with that. Thank you very much for watching the video, and good luck with studying with everything. Thank you.